Let's take a look. So cotangent 25 pi over 6. All right, so what are we going to do with that one? How about I give you a second? I just feel like I'm just whipping these out, so I'm nervous about getting. All right, so yeah, so we want to subtract the extra 2 pi's, right? So subtract 2 pi. And what is 2 pi? 2 pi over 1, multiply top and bottom by 6. So we take the 25 pi over 6 minus 12 pi over 6, and you get 13 pi over 6. That good so far? Everybody see? I'm going to do it one more time. Everybody good so far? I subtracted 2 pi, which is 12 pi over 6. Right, I multiplied top and bottom by 6, subtracted 12 pi over 6. And then do it again, subtract another 12 pi over 6, and you just get 1 pi over 6. And then you go to the unit circle. So see how I'm subtracting the extra 2 pi's? So now go to the unit circle for pi over 6. So pi over 6 is right here, cosine sine. And cotangent is cosine over sine. So it's cosine pi over 6 over sine of pi over 6. And that's, whoops, square root of 3 over 2 over a half. We good there? And then you grab that one on the bottom and you flip it up. So you get root 3 over 2 times 2 when the 2's cancel. Root 3. Just like I told Renee. Root 3. It's all good. It's ancient history. Who knows?
I don't know.
Square root 3, we good?
This part of trig I'm really good with.
Questions I can answer on that? Is that okay? So cotangent, remember, is cosine over sine. You can have that on your 3x5 card. And you'll have the unit circle. We just subtracted the extra 12 pi's over 6, which is 2 pi. Got it down to pi over 6. Then went to the unit circle. Anything I can answer on that? Good? All right. So, okay, so do you remember the way to remember which trig functions are positive in which quadrants?
Number 1.
All 6 trig functions, all 6 of them, are positive in the first quadrant. How about the second quadrant? Sine is positive, and his upside down, of course, cosecant, are positive. The other 4 trig functions are negative. So the way we memorize this, we say all, let me write this again, students take calculus. Is this how they memorize it? Where you're from too? Really? But that's an English thing. It wouldn't work in Farsi, right?
No, just I get a class with
Oh, somebody else. Okay. But in your country, they didn't memorize it this way, I'm sure. Yeah. All right. So yeah, all students take calculus, something that is not true, but maybe should be true. All students take calculus. So,
I've heard black people say feelings.
yeah, no, it might not. Yeah. Anyway, so is that good? Is that making sense? So that's how you remember where they're positive. All students take calculus, meaning all 6 trig functions are positive in the first quadrant. Sine, that means sine, and of course his upside down, they go together, cosecant, are positive in that quadrant, but the other 4 trig functions are negative. In the third quadrant, tangent and his upside down, cotan, are positive. The other 4 trig functions are negative. And the fourth quadrant, cosine and his upside down, secant, are positive. The other 4 trig functions are negative. Okay, so with that in mind, they're going to play name that quadrant. Sine is greater than 0, they're telling me. They want me to figure out which quadrant am I in. It's like, where's Waldo? Which quadrant am I in? The sine is greater than 0. So what does that mean? Greater than 0 means positive, right? And tangent less than 0 means tangent's negative. So could I be in quadrant 1? Is that possible?
Yeah. But it could only be.
But tangent's negative, so I can't be.
Oh, tangent. Okay, I see what you're saying.
Tracking with me? Am I racing ahead? Are we down? Am I doing the Charlie Brown? 1, 1, 1, 1, 1, 1. Nothing's coming across. How are we doing?
Just do it.
So it can't be in quadrant.
Cannot be in quadrant 1, right?
Yeah.
Because in quadrant 1, all 6 trig functions are positive. They're telling me tangents less than 0, meaning tangents negative. We're not in quadrant 1.
Jeez.
Is that good? If we were in quadrant 1, tangent would be positive. They'd all be positive. And they're telling me tangent's negative. So I'm not in quadrant 1. No. Could I be in quadrant 2?
Yes.
Yes, that's where I'm at, huh? Why? Because sine is positive, which is what they said, sine is positive, and the other 4 are negative, which would include tangent, is negative. Yes, we're in quadrant 2. Remember that you go quadrant 1, quadrant 2, quadrant 3, quadrant 4. That good? Hey, I've got an important question. Why do they use, what kind of numbers are these?
Roman numerals.
Roman numerals. Why do they use Roman numerals for quadrant numbers?
They just decided it was cool.
Yeah, I mean, I think it's to make it, in case there's like a point like over 3 up 5,
Yeah.
you know, they don't want to confuse it with the other, I think. But it reminds me of one of my favorite, can I tell a math joke? There's not many good math jokes. This one I think is good. Far Side. Remember you guys ever read the old Far Side cartoon? I thought they were usually hilarious.
I love them.
So, but you got to know a little bit of history. Remember, I'm a wannabe history teacher. Got to do 30 seconds of history. Remember, it's a big deal that Rome fell. You know that from his, I don't know if you know, that's historically, they write gigantic tomes about why Rome fell. It was big. It's bigger than if America fell, for example. If America suddenly fell, like if our economy, in 6 months for some crazy reason just collapsed, and America was a nobody in the world picture, that'd be kind of big. Right now, we're still the economic power in the world. So if America collapsed economically and we became as poor as, some South American country, that would change our lives for sure, and it would change the world, right? That'd be a big deal. Not as big as when Rome fell. Do you remember Rome was around for like 600 years? We've been around like 200,
Roman
250.
the world.
So Rome was around, they ruled the world for like 600. Everybody assumed Rome would never fall. They were the power of the world for like 600 years. I don't know if you have that historical perspective. They were the big kid, way bigger than we have been. Anyway, and then they fell. Why'd they fall? Well, we will get into all that. But one of my favorite Far Side cartoons shows, Gary Larson, was he the did Far Side? Mm-hmm. Anyway, he shows this Roman guy. Have you ever thought about adding and subtracting in the Roman system? You ever thought about, how do they, you know how like if we have 273, we want to subtract 142, 3 minus 2 is 1, 3, 131, we know how to, that's our system. Well, it's not, it's Hindu-Arabic, and it's what we use. So remember Roman numerals? How do you do like 1,000 in the Roman system? I think it's an M. Yeah, I think it's an M. And remember how to make numbers like 4? How do you make 4?
IV.
1 before the V. It said they have like subtraction kind of system. A couple X's, that's 20, right? That's 10 each. And like a D is 500. And you imagine like subtracting like maybe L, isn't L 50? D, X, V. You imagine trying to subtract
No, thank you.
in the Roman system? So anyway, you get, what do you do? Are they lined up? Lining up doesn't matter, actually. Anyway, so they show this little Roman guy, the Far Side cartoon, shows this little Roman guy, and he's trying to do a subtraction problem in the Roman numeral system. It's got all these question marks over his head. He's totally confused. And the title reads, Another Reason Rome Fell. I thought it was great humor, right? They fell because they had a bad number system. That's why they fell. I don't think that's why they fell, but anyway. All right, I hope you enjoyed that. I thought it was hilarious. But, because people write all the books about why did Rome fall? Well, Rome was going to last forever. Anyway, all right. Another reason Rome fell. So let's try another. Where's Waldo? So they're telling me cosecant, or I'll just put it on first screen for y'all. So it says cosecant of theta is greater than 0, and cosine is greater than 0. Okay, yeah. So they're telling me cosecant's greater than 0, cosine's greater than 0, and they want to know theta is in which quadrant. That's the question. So remember, all students take calculus.
No quadrant.
All right, so let's go through fact by fact. Cosecant is greater than 0. What's greater than 0 mean?
Not tangent.
Positive. And this is positive. So they're telling me cosecant and cosine are both positive, huh? So, and cosecant, that's the upside down of which one?
Sine.
Sine. So that's really saying sine is positive, because cosecant and sine are just upside down. They're the same, they're both going to be positive at the same time. They're just upside down of each other. They're reciprocals, right? So they're telling me basically sine is positive and cosine is positive. Where am I at?
No.
Just
Quadrant number 1. Right? Because everything's positive. We can't be in quadrant 2. You think, well, yeah, sine's positive. Yeah, but the others are negative, so cosine would be negative. So we're not there. Tangent 3. Tangent's positive. No. We don't know anything about tangent. Quadrant 4, cosine's positive, but the others would be negative, sine would be negative. And in quadrant 3, both sine and cosine would be negative, which isn't right. So we're in quadrant 1. We good with that? We okay? All right. I'm just going to spend 2 seconds on this one. They're number 7, they're giving me sine and cosine, and they want the other 4 trig functions. Just put them together, right? There's nothing to do there, right? Tangent is sine over cosine, and then these are flip it, on you go. That good? I'm not going to do any more on that. Is that okay? So that'll be easy for you?
Yeah.
So when they give you sine and they give you cosine, they're giving you all of them, aren't they?
so all is there, so
Because you can give me.
Yeah. Right. So I'll move on. That's okay, right? It's good. Well, here, I'll finish this one. Sine over cosine, this. No, I got to get to the big. Yeah, so here we go. So we're on number 9. If you've been dialed out, dial back in. This is super important. This is probably the most important thing we're doing today. There'll be like probably 2, maybe 3, probably 2 on the next exam. 2 of these. These are really important. Final will have at least 1 of these. Calculus, you'll use this. If you're going on into calculus, you use this a lot. Pre-calcul, we're in pre-calc. Calcul use this. So yeah, these are really important. Drawn triangles in various quadrants, really important. Okay, so let's actually just draw what they're saying. They're saying quadrant 3. Let me get a little more room here.
Everything's gonna be
So quadrant number 3, I'm going to put theta in quadrant 3. Now, when you put theta in quadrant 3, start at the origin, go into quadrant 3, and it's really important. There's 2 ways I could go like that, or I could go like that to make a triangle to an axis. One of them is right, and one of them is wrong. Are you aware of that? Do you remember that from Trig? Which one do we want to do? And why? Anybody remember?
because it maintains the x value as being
no x because it should be the x side.
negative.
You're saying we do the 1 to the x.
Yeah, to x.
Correct. We go to the x, not the y. Does anybody know why?
Negative.
Because of reference angles. Because we're going to put theta right there, but theta is actually the angle from here. We're sort of cheating. Sort of. We're making the reference angle the same. Do you remember reference angles? Did you... What is a reference? Somebody said, what is a reference angle?
Say for instance you have 150 degrees. You go to 180 and then you would subtract.
Right.
how-
It's how far to the nearest x-axis. So reference angle means with reference to the nearest x-axis. So my point is, where did we start off with 0? Where's 0 actually?
0.
Right here at the x-axis. You see, because they started off at 0 degrees being the x-axis, they could have made it straight up, like a clock. But they decided to make 0 the x-axis. That was random decision. But once they did that, then you want all your angles going to the x-axis to be the same values. What do I mean? I probably am spending too long on this because I have other things to do. But basically, you see, the theta angle is actually from 0. It's really there, but it's going to be the same values for sine, cosine, and tangent if you'll just make theta only be here as long as you go to the x-axis. I'll prove it later. Let's just move on. We better move on. So step number 1, draw theta from, draw your triangle from the x-axis. It's got to be from the x-axis because 0 degrees started on the x-axis, not the y. So we've got to make all of our triangles to the x-axis so the reference angles match. I'll give more details later. Let's keep going. So now, what do you do next? Do you remember Sohcahtoa?
Yes.
Sohcahtoa. 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 All right, so Sohcahtoa. What does that stand for?
Sine over hypotenuse.
Sine is opposite over hypotenuse. Yeah. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Yeah. Remember Sohcahtoa? So that means they're giving me cosine here. Cosine is what over what? So this must be adjacent. This must be hypotenuse.
R is always positive.
Right.
Yeah, you can also think that.
Good there? Okay, so now let's go back. Let's take that information back to our triangle. So here's your angle theta. So what is this side is the hypotenuse, isn't it? It's the side across from the right angle. Hypotenuse is always the longest side across from the right angle. Okay. This is the opposite side. This is opposite from theta. He's across from theta. And this side is adjacent. Adjacent means next to it, like your neighbor lives adjacent to you, next to you. So adjacent, so that's the side next, it's touching theta. It's next to theta, right? This is the opposite, and this side's hypotenuse. Okay, so with that in mind, let's just scribble in our triangle. Let's put the information in there. Adjacent is minus 24. Hypotenuse is 25. Good so far? So now I've got to find the opposite side. So step 2 is do Sohcahtoa, and step 3 is do a squared plus b squared is c squared, right? That's a right triangle. Do the Pythag to find the missing side. So step 1, draw your triangle, or I should, instead, why did I say from? 2. Draw your triangle to the x-axis. Step 2, use Sohcahtoa. Step 3, do the Pythag. So let's do the Pythag. So when you do the Pythag, the a squared plus b squared is c squared. Again, all that matters is that you get the c right. The a and the b order doesn't matter. So which one's the c?
25.
The 25, correct. Everybody good with that? The c is the 25. The other two, doesn't matter. I'll just go minus 24 squared plus b squared. Or you could put it in the b or the a. It doesn't matter at all. Use your calculator. I think that you'd have your calculator on this part. That's 576. That's 625. Finish solving for b. Subtract 576. So I'm getting b squared is, oh yeah, 49. So then it is going to be 7, huh? Square root, b. So you could do plus or minus, but we don't have, it's the side of a triangle. Well, actually, no, I'm sorry. It is plus or minus. Plus or minus. Now, how do we know if that 7, which is that other side, huh, is plus or minus? Yeah, based on back and down, so it is negative.
And you also could think of it because that's a tangent quadrant that's positive.
Yeah, and we can do it that way too. Let me slow down for a minute. Are we good to there? So everybody see what I'm doing. So again, step 1, draw your triangle to the x-axis. Step 2, do the Sohcahtoa. So I looked up and said, okay, your cosine, you're adjacent over hypotenuse. And I put adjacent and hypotenuse on there. Then I did the Pythagorean, solved for the other side. Now the signs, it's back and down, so I know they're both negative. Yeah, the hypotenuse, we always leave that positive. Positive 25. Okay, now we're ready. Now we can finish. How do we do it? Now what do they even want? I didn't say what they want. They want all 6 trig functions. So now we can do them. What's the sign?
Opposite over hypotenuse.
Yeah, sine is
7.
opposite over hypotenuse. So that's opposite, which is negative 7 over hypotenuse, 25. Cosine, I've had that from the beginning. Negative 24 over 25. Tangent. What's tangent always? What's tangent here?
Adjacent.
Opposite over adjacent. Toa.
It's going to be 7 over 20.
Negative 7 over negative 24, which comes out positive, huh? 2 negatives make positive. And the other 3 are flip it, aren't they? So I can say cosecant is negative 25/7. Secant is negative 25/24. and cotangent is positive 24/27. And we're done. We found all 6 trig functions from that information.
Remember the videos? Find the 6 trigonometric functions.
Questions that, well, we're going to do a couple of these, at least one more. Questions I can answer first off, though, on that. How are we doing? Questions I can answer? Does that make sense? So step 1, draw the triangle to the x-axis. Step 2, use Sohcahtoa. Get 2 sides. Step 3, use the Pythag to find the 3rd side. And then you got them all from Sohcahtoa. Now, one thing you can do, if you don't want to worry about the signs, I remember my own daughters, when they were doing this, they got confused by all the signs, and so they would just double check at the end with the all students take calculus. You could do that. If you want to just say, look, I'm just going to leave all these numbers positive, just do my triangles, and then at the very end, just double check. Remember, all students take calculus. So I'm in the 3rd quadrant. So tangent has got to be positive, he is. And his upside down, cotan, he is. And the other 4 have to all be negative. They are. So you could just do it that way. Or you could double check that way too. If you want to just not worry about signs to the end, you could just do that. Good on that? Want to try one of those? Okay, want to try that one? Cosine theta is minus 1/5. So try to go through those steps that I wrote out for you. So step 1 is draw your triangle to the x-axis. Step 2 is Sohcahtoa. Step 3 is the Pythag. A squared plus b squared equals c squared. And step 4 is you can get them all once you have that information. What quadrant are we in?
3.
Yeah, because this is pi, this is 3 pi over 2. See how the angle theta is between pi and 3 pi over 2, so we're in the 3rd quadrant. So you start at the origin, you go out, and then you go to the x-axis, always to the x-axis. And you put your theta right at the origin. It'll be a reference angle. It'll be the angle to the nearest x-axis. And then Sohcahtoa, cosine's adjacent over hypotenuse. So back 1, 5, do the Pythag. So it's going to be a squared plus b squared is c squared. The c is 5. So a squared plus negative 1 squared. A squared plus 1 is 25. A squared is 24. Root it. And the square root of 24 is 2 root 6. Yeah, and then it's negative because it's down. If you want to just not worry about signs, and you could just do that at the end. Is everybody okay with the square root of 24 is 2 root 6? Right, I can do that up here. 24 is 4 times 6. 2, 2, 2, 3.
Negative 5 root 6 over 12.
2 2's in. Leaves 1 2 out, so it's 2 root 6, It's plus or minus. It turns out it's minus because it's back and down. We always have the hypotenuse positive.
Root 6 is 1 6. It's just 6.
Is that okay? You all getting to that point? So then we can get the 6 trig functions. Is everybody to there? Are we okay to there?
Yes.
Do you want me to wait? So then sine is Sohcahtoa. So sine is opposite over hypotenuse. So that, yeah, I like to write them in. This is the adjacent side, opposite side, hypotenuse. So opposite is minus 2 root 6 over hypotenuse over 5, like that. Cosine we've already had from the beginning. Tangent, toa, opposite over adjacent, opposite, negative 2 root 6 over adjacent over negative 1, 2 negatives, positive 2 root 6. And the other three, flip it, flip it, flip it. Can I just skip that? I want to go to another one.
Okay.
You got roots in the bottom, and I don't want to mess around with that. Is that good there?
Dot.
Yeah, dot, dot, dot. I used to hate it when teachers did that.
Yeah. No.
Are we good, though? Anything I can answer to that point? We good with getting those? All right, so what quadrant are we in? Secant is really cosine, positive. 4, that 4 is positive, isn't it? So they're telling me cosine's positive. Because secant is upside down to cosine, right? So if secant is positive, then cosine is positive. Cosecant's upside down to what?
Over
Sine.
Sine, and they're telling me sine. So they're telling me sine and cosine are positive. What quadrant are we in?
just one.
Quadrant number 1. Roman numeral number 1. So we're in quadrant 1.
Since secant is a whole number, doesn't that mean that R is 1? Oh, no.
Nope, can't do that. Nope, just do regular. So everything's normal. So right here, quadrant 1. We always go to the x-axis, right? Put your theta right there. Quadrant 1. Good. Are you guys getting this okay? Changed to Spanish today, huh?
Yes, I did.
Like when Buzz Lightyear got put in the wrong mode. Sorry, Toy Story. So they're coming out with a new Toy
They
Story.
can say German instead.
Ja. Nine.
That's leaving German instead.
All right, so here we go. So step 1, we did the and step 1 we did the draw the triangle thing. We drew the triangle, quadrant number 1. Step 2, Sohcahtoa. So now cosine, if they're telling me secant, I'm going to change that secant fact to a cosine fact. Cosine must be, if secant is 4, what's cosine? 104, right? Because they're upside down of each other. So, and cosine is adjacent over hypotenuse. So let me see, this is the adjacent side. This is the opposite. This is the hypotenuse. So adjacent 1 over hypotenuse 4. So now I do the Pythag, huh? Step 3, a squared plus b squared is c squared. So that's going to be 1 squared plus b squared is 4 squared. We good there? Just got to make sure you get the hypotenuse to be the one alone. 1 plus b squared is 16. B squared is 15. Root it, plus or minus. B is plus or minus root 15. In this case, it's plus because it's up, huh? It's right and up. They're all positive. Everything's positive in the first quadrant. How are we doing? Is this making sense?
Yep.
I'm racing ahead of you. See what I did there? So I just took that secant, made it cosine as 1/4. And now you can finish the problem. So now we can say, okay, we can get them all. Sine is Sohcahtoa, opposite over hypotenuse, opposite, root 15 over the hypotenuse of 4. Cosine 1/4, right? We had that back here. Tangent, toa, opposite over adjacent, opposite, root 15 over adjacent 1, so it's just root 15. The other 3, flip it, flip it, flip it. Everything's positive, first quadrant. Good on those? Those are real important. Any questions I can answer? Like you can do those? All right, okay, if I flip. Even, odd. So first off, remember, if a function is even, then f of negative x is f of, it just becomes positive. And if a function is odd, when you plug in a negative x, it comes to the front. So odd, let me put it in words. An odd function, plug in negative x, the negative goes to the front, like that. Even, plug in negative x, negative becomes positive. So we had that I don't know, month and a half, 8 weeks ago, 7 weeks ago, something like that. Even and odd functions. Remember, it comes from, anybody remember, where do you get the word even and odd? It comes from something like x squared, even power, odd, x cubed, odd power. If you plug negative x into x, what would negative x squared be?
Always positive.
Positive. And what would negative x cubed be? Well, the negative would come to the front, huh? That's where they're getting the even odd idea. So they're saying if you're an even function, you're like x squared, plugging in a negative just becomes positive. If you're odd, you're like x cubed, plugging in a negative, the negative comes to the front. Okay, so they're going to apply that to trigonometry now. Basically, here's the deal. Sine and tangent are odd, and cosine is even. And their reciprocals always go with them. So sine, cosecant, tangent, cotangent. So what does that mean then? That means if you have the sine of a negative angle, the negative comes to the front. If you have the tangent of a negative angle, the negative just comes to the front. So you never have to do negative angles. That means, let me do a particular angle. That'd be more helpful. Somebody says, hey, what's the sine of negative 30 degrees? You don't have to look up negative 30 and just put the negative in the front and just do the sine of regular 30 with the negative in the front. So you don't have to, and cosine's even better. Cosine's even. So if somebody asks you, what's the cosine of negative 30? You just make it positive. You ignore that negative completely. It's the same thing as positive cosine of 30. So this is a way to never have to deal with negative angles. They'll either come to the front or vanish completely. Does that make sense? If you're talking sine or tangent and you put a negative in, it comes to the front. If you're talking cosine and you put a negative in, it just goes away completely. It's positive because cosine's an even function. So that's the even odd property. So sine and tangent, and you know the way I remember it? I have a bad memory. So I had to make it with tricks. So can you see an easy trick? For me, it was all patterns and tricks. I'd make up lots of dorky sayings, too. I don't have any of those with me. I just did them in order. Sine, cosine, tangent. 1, 2, 3. Do you see the trick for even, odd?
Wow.
Cosine's an even number. Sine and tangent are odd. That's an easy trick, right? Those are the kind of tricks I did to survive college. I did that for all my classes, to memorize the things. It helps. Good. So cosine's even. Sine and tangent are odd. 1, 2, 3. Sine, cosine, tangent. All right, so let's get to the actual question then. They're saying use this to figure out the tangent of negative 30. Okay, tangent, is he even or odd? Odd, 1, 2, 3, 3. So what's that negative going to do? Vanish or come to the front?
Come to the front.
So that negative, so it's a tangent of negative 30, that negative will jump to the front, be negative tangent of 30. So then you just go to your unit circle. Let me go find the unit circle. Where's 30? Cosine sine. Right there, root 3 over 2 1/2. So tan negative sine of 30 over cosine of 30, right? Tan is sine over cosine, right? So that's negative, what was sine?
1/2.
I forgot already. Yeah, half. Half over root 3 over 2. Grab that one in the denominator, flip it up. So it's negative 1/2 times 2 over 3. They cancel. Whoops. Negative 1 over root 3. And we can't have roots in the bottom. Can I go dot, dot, dot? Just multiply top and bottom by root 3. Negative root 3 over 3. Done. Good. So you never have to look up negative angles. You can always either bring them to the front for sine and tangent or make them positive, ignore them completely for cosine. These properties allow you to never have to deal with negative angles. They either come to the front or vanish. Come to the front for sine and tangent, vanish for cosine. Make sense? So the negative just came to the front, and I just did tangent of regular 30. I didn't worry about negative 30, right? You know what I mean? I didn't look at the unit circle, oh, I got to go down 30. I'm doing a 30. Whatever. I just did positive 30, right? I just did positive 30 and threw the negative in the front. So you never have to worry about negative angles because of these properties. These are times. Any ideas what the answer is?
That one number.
Answer is what?
Isn't it 1?
1. Right.
Yeah.
Right, because they're upside down. So now we're talking properties. We're saying this is 1 over sine, isn't it?
Oh.
Remember cosecant's 1 over? Cancel 1. Good? So now they're going to give us some property. They're going to say, do you remember the properties? There's easy ways if you remember the property. Next one is more tricky. Cosine 394, so 18.
So we are doing a little.
Cosine 394, secant 34. Yeah, I guess we do a little bit, huh? No formal proofs, though.
1.
You know, those are the worst.
So, is that one 1 also?
No, because there's a.
What do you do with 394?
This is one.
I'm with Renee. I'm thinking it's 1 still. What do you do with the 394? What do you do whenever an angle's more than 360? Subtract 360, right? Because that's more than a full rotation. Just bring it back within 1 rotation. That's cosine 34,
Oh, the referencing.
right?
Yeah.
Right? Whenever you go more than 360, who cares about that extra rotation? Get it out of there. So then secant, remember secant is 1 over cosine. 1. If in doubt, guess 1. So we have time for one more. Yeah, it's more. That's
One